so let's get back to talk about more design patterns. Okay, so we'll talk about more design patterns with some examples. Okay, so first of all, let's look at creation of patterns. So these are the patterns for creating objects. Okay, so I'll give you the quick review at the end on overall the patterns that we look at. So now let's look at these two patterns called factory method and abstract factory. I will show you how these two pattern works using a sample code. Okay. And then we will look at the actual pattern itself. Okay, so let's look at the example first. So this is the previous game that we wrote. Okay, so you have this this ball, and if you actually hit the red one, right, you recall that, then you move fast. Okay, so that's the idea. Oh, sorry. Okay, so now if you, oh sorry, so currently if you move slow, you can fire a fireball. Oh, not like that. So there are two types of fireball. Okay, one is this curvy fireball. Okay, and there's another called just a fireball. So currently our code just find a fireball. So now this is a simple ball. Okay, basic ball. So this is class fireball, and if you create an object called curve fireball, it will give you a wiggling fireball like that. Okay, now I would like to I would like the game to be such that if the dot is not excited, it should just fire a fireball. Okay, but if it's excited, like when you hit the red dot like that, it should fire the curve ball, the curve fireball. Okay, so let's fix the code on that. So right now, because we have already applied the state pattern, so the dot would be in either excited state or in dot normal state. Okay, so and then I have the code that if the user press any key, you change the direction, but if you only press a space, you would fire a fireball. Okay, by calling dot fire, and this dot fire would basically create a ball like that, and then add it to the game element, and this ball would just run around and around. Okay, and if it reach the end of the screen, basically the element will be hidden, and then it will be removed. Okay, basically, but we're not gonna look at that too much. Okay, now since we wanna the fire method to behave differently on different states, so we would actually take this fire method, okay, and put it in state. So we would call cell.state.fire. Okay, and we would take this code and put it in these two states, normal state and excited state. So we say fire like that. So okay, so we create a curve fireball, and so if you are excited, let's create a curve fireball, and if you're not excited, let's create just a fireball. Okay, and then you would access this cell.gamef cell. dot, okay, because I just moved it from tail dot 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 x, tail dot 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 y, and then we would say dot dot game x. So this is the code for fire in the state, okay, and this is also the curve for. What's different here is just it's a curve fireball, and the upper here is just a fireball. Okay, so let's see if it works. Here you just have a ball. Okay, and now let's see. When it's fast, it creates the. This is just come back to a normal fireball. Make sure that I hit it. So now it's curvy now. When after it's finished being excited, it comes back with just a fireball. So the code works. Okay, but the problem with this is that basically, if you look at this code, it basically look the same, right? Almost the same, except that you change the class that you would like to create a fireball. Okay, so you change the class, but everything else is the same. And situation like this happens all the time. Basically, the only difference between the excited state and normal state is not how the fire method works, but it's on the actual class of the fireball that you will create. Okay, so to deal with this problem, okay, you would basically create a method called, so we would encapsulate that and then create a method called create fireball. Okay, and for here, for dot excited state, we would return curve fireball, and for dot state, normal state, we would return, on the creation of that, we just return a fireball. Okay, and we would basically take this method fire out. Okay, and we would just do this. We create a base class called base dot state. So you can either let the dot excited state to extend the dot normal state. Okay, we can do that, or we can create a new dot base class. I'll do this first. Okay, and we say define create fireball. So we have this function that we haven't done anything. Okay, on the fire method, we do this. Okay, we can even leave this out, but let's leave it there for a bit. Okay, and then we would say dot normal state is base dot state. And we just throw away the fire method. Okay, so let's run it. It's curvy now. Okay, it's normal. Okay, so everything works. So basically, we create this method. This is called the factory method. Okay, so it's a factory. It's a method that creates something. Okay, and we use this factory method to create a fireball, and this fireball will be used in other method called fire there, that basically whatever fireball that you use, it will works the same way, but depends on the type of fireball that you create, thing would be different. Okay, so you keep the method fire being the same in both states, and you only the only difference is the factory method for creating a fireball. Okay, so this is the factory method. You can even do this. Okay, you can look at the excited state, and you can say the excited state is just the inherit from dot normal state, and you put the file method inside the dot normal state. That would work fine too. Okay. Basically, I might wanna delete. Typically, I usually leave this function like that, so that if you actually accidentally create base dot state, you can still call base fireball, but you're probably not gonna put it there. Okay, you don't need to put it there. Okay, or you can raise exception to prevent the user from create this dot base dot state. Okay, but I'll leave it like that. Okay, so this is called the factory method pattern. Okay, now if you want to, suppose you're not gonna say this dot not only can create a fireball, you can hit the other thing to do something else, like 3 or 4 types. Okay, you can end up with something like this. If you start having many factory methods, like create fireball, create water magic, create special ball, create wind magic. Say you can do many things, like create so many things. Okay, like in this class normal state, this Pac-Man has to create a bunch of things, so you have a lot of factory method like this. You also need to do that in this dot excited state as well. Okay, so now the other code would use factory method to do many things. Okay, now turns out that when you have a lot of factory method like this, it is nicer to encapsulate all this into an abstract factory. Okay, a factory is an object with a lot of factory method basically. Okay, so we would like something like this. So we would call so we would say class dot normal factory, and we just take all this into a factory itself. In Python, you don't need the abstract class, because you can just do whatever you like, because it's a dynamic language, and it won't do the type check for you. So we have class dot excited factory. So you have two factory, the dot normal factory and the dot excited factory, and then on this state you can have a dot normal factory over here, and here you can have just a dot and then here it's gonna be dot excited factory, like that. Okay, when you want to create something, you go through a factory. Okay, so you can group a bunch of create factory method together so that you can create a bunch of stuff. Okay, you can either, when you do here, it's easier to use because dot normal factory is tightly coupled with the dot normal state, and dot excited factory is tightly coupled with dot excited state. But you can even decouple things further by allowing the user to just add the factory here, and we just say self.factory equal to factory, and then when you actually create a fireball, when you say self.factory create fireball like that. Okay, so this is just example because you actually need to pass the dot to the factory as well, so take some time. You need to actually fix this code, but the idea is basically that. Okay, so you can have a factory. A factory and abstract factory is basically a common factory for that combine, you know, all the factory method. Okay, so let's look at the slide quickly. So this is the factory method. So basically, when you want to create something, you define. So again, because you use the design pattern has been invented to solve a problem for C++ and Java. So many idiom or many construction depends on having abstract class and inheritance. But here in Python, you can just throw in any object, so you don't need this basic class. You need this class to have this factory method. Okay, so when you want to create something, you have this factory method to create stuff for you. Okay, so when you want to change the way you create stuff, you change the creator object. Okay, then you can have different creator that create different stuff depend on the thing that you would like to create. So this is called the factory method. And if you combine a lot of, like, you want to create product A and product B, and there are two variations like concrete factory. So the first variation create a kind of product A and B in a particular way, and this another variant, the concrete factory 2, create product A and B in a different way. Okay, so the product A, you have product A1 and A2, and product A1 is going to be created by concrete factory 1. Product A2 is going to be created by concrete factory 2, like that. So with this is called abstract factory. So you have an abstract class that basically define all the way you create stuff, and the actual way you create stuff with we actually use the factory method here, right? When you actually create stuff, you has a class that actually creates something that the client wants. Okay, so if you pass the particular kind of factory method class to a client, the client would already get all that kind of thing. Okay, so think of it this way. Suppose you want to build a room, and a room should have a bed and a sofa and a table. Okay, and you wanna, so you can have two factories. One is a classic factory that create a classic bed, a classic table, and a classic sofa, and you can have a modern factory that create a modern sofa, a modern bed, and a modern table. So this is like two concrete factory, modern factory and a classic factory, and they are all inherit from an abstract factory that allows you to create a bed, a sofa, and a table. So that's the idea of the abstract factory pattern. Okay, so next we'll look at structural patterns. We look at bridge. We will go very briefly on bridge here by looking at our game lib. Okay, so our game lib, if you recall, we start with the code from Ajahn Chaiporn, and then we sort of like encapsulate all the implementation into this game app class. Okay, but this game app class depends heavily on TTK frame like this. Okay, Now if we want to work on game app, and then we need to somehow to understand TTK frame, and it's tightly coupled, and if you want to work a little bit on how we implement with the TTK frame, we still need to work with game app, right? So if you want to apply the bridge design patterns, we would basically split these two things. Okay, we would create an implementation class for game app that actually use TTK frame, and then we would allow game app to have that implementation to use it. Okay, so the idea is that we would have the game app implementation, which should be a TTK frame. Yes. And then here game app will be just game app. Okay, and it would have the implementer. This is gonna be the actual implementation. That would be the way we call game app, and then we pass and we create it. Okay, like that, and then we don't need to call super. Okay, because right now we not TTK frame anymore, we just something else. Okay, and then this TTK frame thing, we need to somehow throw away our dependency on TTK, just like parent.by. All this is to we just call by at the implementation of this. Okay, and when everything we do exactly with this class, previously we inherit from TTK frame, right? Right now we are not TTK frame anymore. We have an implementation with TTK frame. We will just call the, instead of get the canvas from itself, we just call the implementation. So we fix a bunch of things. I'm not gonna actually show the whole thing to you, but it's like we split the game app into the abstract game app and the actual game app implementation that depends on TTK frame. Okay, okay, so let's look at the slide. So previously everything that we have is here, and then it's in here, but we split TTK frame part into the part of the implementation, and then everything that we do, we just call the implementation on here. So our game app class is free of the implementation details, and we can work on it without actually having to depend on the implementer here. Okay, so if you look at the image from the refactoring guru, so this image from refactoring guru is kind of like nice. So previously you combine the whole thing here, but then you split it into abstraction and implementation. So in our case, this is the abstract game app, and this is the implementation part of game app that depends on TTK frame. Okay, so with this bridge, it's implementation bridge, right? So you split the work into two parts, that the implementation specific changes will affect the other one of the tower here, and the abstraction, the change that affect the abstraction part is gonna be deal with in this class. So this is the bridge pattern. Okay, so so that shows quickly how to use the bridge patterns. All right, so I'm gonna go really quick about the adapter patterns. I'm not gonna show you the code even. Okay, so in adapter pattern, you have a client, and you want to use the client would like to use something, but it has some particular API that it's familiar with. Maybe you have a bunch of class with the same API, and then you have another class from someone else with different API. So how are you gonna apply use this with the other class that you wrote by yourself, you can use the adapter pattern. So basically you have a class that wrap around, that hides all the difference, and wrap. It's a wrapper class, so it's wrap over the actual implementation class, and it acts as an adapter, so it changed the method call from one API to another without having to do too many things. Okay, so this is just an adapter. So think of it as a power adapter. It doesn't change anything much, but it changed the way the electric plugs put together, right? So that's the idea. Okay, so that's the adapter, or people sometimes refer to this as a wrapper. So the last, okay, so the other structural patterns that we look at quickly here is the facade. Okay, so the facade is basically is the front facing of a building. Okay, so basically, if you have a complex system, maybe part of the system that you write on your own, or maybe you actually has the legacy code from someone else, and you want to simplify the API, the way you interact with that. So you can create a new class that hides all these implementation details and only expose part of the interface that you would like the client to use. So this is called the facade. So basically it's like that. You have a bunch of function, you might write it, or somebody else would write it, and then you, and this is your code, and your code would like to work with this library. Okay, but maybe it's really difficult to write, to work with that library. However, if you look from the point of view of the client, maybe the way you would like to use the library is really simple. Like you want to call something, just one function on it, but it needs a lot of setup and do some overhead and something like that. Like in this example, you want to do something, but you need to create this tree class and call this and that and this and that. So you can somehow encapsulate all this and expose all the functionality in such a way that it's easy for the client to use. So this is the facade design pattern. So basically you hide all the details at the back with a simple nice looking interface like this. If you look at from the far, you probably don't see that you're hiding stuff inside, right? But it's just nicely front face of the building. It's a facade, right? So this is the facade pattern. Okay,